Yeah, so this is a brand new house, 2 million something. It's in Arlington, so it's on a hill. The other $2 million house up the hill behind it has all this drainage. And rich people don't like utility wires in the air across their yard. So that they had to set a pole up the hill behind this house so they could run the wires underground. Well, the guy who was putting the conduit together at the pole had trouble bending the wires. So he cut the conduit. All the drainage runs down to from the house above down to this pole. That's higher up than the meter. So when it started pouring, the pump started running right down into the conduit, down the hill, up into the meter. So Dominion Power, being somewhat logical, cut the power, got everybody out of the house, except Granny. She wouldn't leave. She's there with no power for a few days while they sorted the whole conduit issue, which requires disconnecting. Yeah, anyhow. So this is not about electric shock. This is about the anaphylactic shock that some guys are going to go into when I tell you what I do. I open the panel, grab my 1,000-volt rated insulated screwdriver, and I check all the connections. Yeah, well, yeah. And that puts some people into anaphylactic shock. There we go. So when you're looking at stuff, make sure you get a good look at it. Don't miss the missing eyebrow, guys. It's usually there. Listing and labeling. Everything electrical is listed and labeled. Electrical materials, components, devices, fixtures, and equipment shall be listed for the application, shall bear the label of an approved agency, and there are numerous approved agencies. They're listed in your code check and in your code check illustrations, and shall be installed and used or both in accordance with the manufacturer's installation instructions. There's some stuff you should remember. When I talk about listed and labeled, you're in a 1968, 75 house, and they have tile backsplash in the kitchen. You better be pulling a cover plate, because when they put the tile on, that box ended up being recessed. Okay? And the receptacle is now installed with drywall screws. Show me a box of drywall screws that's listed and labeled. Not going to find it. Max height of a breaker handle is 6 foot 7 inches. So this won't apply to an older house, 30 years old probably, where the damn thing you have to get a step ladder to check the panel. Newer construction. AFF, above finished floor. Not allowed where subject to physical damage. Like in front of where you park the car. Closets, easily ignitable. Bathrooms of dwellings, dorms, or guest rooms. And certainly not over the steps of a stairway. I think I've only seen 2 of those in 37 years. This is in your code check. It's also in your code check illustrations. If you have code check illustrations, You can send it right to your phone if you don't want to remember all these numbers. 10 foot, 3 foot, 3 foot, 3 foot, 8 foot, 12 foot, 18 foot, 10 foot, and on. But you can just keep it in your pocket if you have it in your phone. Everybody knows, I hope, working space, right? Everybody. Okay. Must extend to the floor or grade and cannot be used for storage. Usually it's the washer or the dryer. If it's the dryer, I move it. If it's the washer, no. Boxes, too deep, or the gap around them is more than 1/8 of an inch. It's easy enough to put the extenders in. This is for all light switches, receptacle outlets, light fixtures. It's a little different for a panel. Since 1992, if a panel is set in wood framing, so it's attached to 2x4, it has to be flush or protruding from the face of the drywall. Get back before that, it's kind of whatever. But the same thing about the max gap to the wall surface applies. It's still only 1/8 of an inch. When they damage the concentric knockouts, there are ways to fix that, and you'll see some of that later on. Armored cable. That's what it says. AC cable, armored cable. You should always be looking for the, where do I see this? Are we turned on? Buzz. It just buzzed at me. What does the buzz mean? Do I need a gizmo? Do I need to load a program?
Yeah.
Is it going to run with an old computer?
No, it won't do the thing. See, they can't see that. Only you can. Yeah, you don't have a pointer.
Oh, bummer. No, it's just, it needs to be
installed.
Needs to be installed. I have it on my old computer. Anyhow, you should always see the anti-short bushing, the little red plastic thing. And a lot of people get confused, apparently from what I hear, by the bond wire, the aluminum bond wire that's inside the steel jacket. That is not a ground wire. It does not go into the panel. Okay? Now we get to the part about the drywall screws and the sheet metal screws and scraping paint. That's the way it is. This is all right out of code check, as you can see. I'm sure you're familiar with all this. They call it a cable guard. I call it a running board, but because it runs along the wire. Board holes have to be 2 inches from the surface, and you can't wire on the face of the framing, or you're not supposed to. I'll say you're not supposed to. You can do it, you're not supposed to. We don't see much knob and tube, granted. So the reason I put this in was because it mentions the copper wire that's coated, which a lot of people have mistaken over the years for aluminum wiring, not aluminum wiring. And even back in the 80s when I started, we were taught to just take the screwdriver and scrape the coating a little bit, and if you see copper, you know it's copper wire. You can also usually see an end sticking out somewhere, and you see the copper. No scraping required. We have underground feed. I think, if I remember correctly, decades ago it said it was marked UFUV, I think. And M, of course, non-metallic. for normally dry locations.
You say UV for ultraviolet.
I'm sure it used to be stamped UF-UV. Now they just call it UF, but it is UV. It's for outside. This one's a little trickier because it's in the attic, and we don't want you tromping through the insulation and smashing it, because then you got to fluff it back up or buy them new insulation. So this is your pre-84 60-degree wire, and this is your new retrofit can light. Now, I would have recommended they just get the pancake LEDs, but that's me. Who wants can lights anymore? New wires, 90-degree. The 60-degree wire should not be going to the box that's next to the can. They have to set another junction box. The new junction box has to be accessible. Here we go. Where is the GFI under the whirlpool? It's over there to the left of the door, inside there, facing the back of the tub, or facing into the tub, where it's on the right, facing the other direction. Really, Mr. Builder, Mr. Electrician? Receptacle within 6 foot, GFI protected. What about the one for the tub? Well, the people who make this stuff came up with this genius thing. Whoops. It's called a blank face GFI. You stick it on a wall, light switch height. I think the last one I saw was around the corner down by the toilet. I looked at the builder and said, why don't you put it back around the corner up here at light switch height instead of down by the toilet? I'm like, yeah, I guess we can move it. Good for you. Service disconnects. What's working space? 30 inches wide, 36 inches deep from the face of the panel. Where is the AC disconnect, the heat pump disconnect? It's always behind the heat pump or the air conditioner. Duh. Okay. Although I haven't heard it lately, I have heard people talk about overcurrent protective device. And, well, the electrician says you're allowed 30% plus or minus, or 20% plus or minus, or the HVAC tech said, oh, it can be 10% over, whatever. No, the mark size on the data plate is what it is. Max, fuse or breaker, it's right there. This is from the 21 code check, the thin book. This is from the 22 code check, and they specify working space, and they still specify max overcurrent protective device. You all know about weather resistant receptacles, right? Hello, anybody? Yeah? Yeah. So what do you say when you see an old receptacle behind one of those not weatherproof boxes? Change the receptacle. Now that one does have weather resistant. It's marked WR, you can see it. So I tell them, change the receptacle, put in an in-use box. Bonding. All interior piping systems capable of becoming energized must be bonded at an accessible location. So I don't really have much on CSST today. Who was talking about that the other day, Hollis? Somebody.
I was.
There are
When you came in my
there's
class,
flash
we were
shield,
talking about
flash shield, and counter strike. Those are the black covered ones. Flash shield has a wire mesh in it under the rubber jacket, and they have very specific install on it. Counter-strike is just a rubber covering of some kind that they say absorbs the electricity somehow. But those pipes still need to be bonded. I just treat them like CSST. If it's going to a furnace, it's bonded by the ground in the furnace, just like steel pipe is. But because it's stainless steel tubing, and even though it doesn't have a yellow jacket, I still suggest that they go ahead and get it bonded.
All right, so while we're on CSST, let's talk about, make sure everybody's aware of the language that's required by Virginia and Maryland, yeah.
So Virginia says if it's built before the before the 2008 code.
2008
code. So if you're working in Fairfax County, the 2008 code probably didn't come in until 10 or 11. But they say if it's built before 2008 and has a yellow jacket, it's got to be, they say, grounded and bonded. I don't know, I should have pulled that up.
But the language of the regulation requires that the home inspector include in the report, if you find the yellow CSST in a house built prior to 2008, that you use the very specific language. You have to copy and paste from this regulation into your report a statement that says manufacturers believe that this product is safer if properly grounded and bonded, and that grounding and bonding can only be confirmed by a person qualified to perform that service, which would be an electrician, a licensed electrician. So it's very specific language. If you get a complaint to DPOR, they're going to look for that, and if it's not there, you're going to pay a price.
Do you have it pulled up, Tony? What does it say about who can determine?
Read it exactly word for word.
Yeah.
I was going to do that.
Yeah. No, go ahead.
I did pretty good there, didn't I?
Yeah.
Yeah.
If a home inspector observes the presence of any shade of yellow corrugated stainless steel tubing during a home inspection in a home that was built prior to the adoption of the 2006 Virginia Construction Code effective 1 May 2008, he, not she, shall include that observation in the report along with the following statement, quote, manufacturers believe that this product is safer if properly bonded and grounded as required by the manufacturer's installation instructions. Proper bonding and grounding of the product should be determined by a contractor licensed to perform the work in the Commonwealth of Virginia.
Should be. Does it say it has to be? It says should be. Can you look at it and see if it's bonded? You can't.
All right, so we're required by the license regulation to include that language if the house was built prior to the adoption of the 2008
code.
No?
Yes, which became effective in
What does it
2008.
say?
Became
Okay.
effective in 2008.
Okay.
In my law school days, this was called weasel wording.
Right. Right. Okay, so in Virginia, it's saying if it's yellow and built prior to 2008, because they're assuming that the county inspectors would have picked up, or would become responsible for it after that.
Right.
Right? Okay, that's what's required in Virginia. In Maryland,
Oh my gosh.
okay, it doesn't address the color, right? Maybe you can pull this up too.
It
But
addresses the font size.
Well, okay, so it says it doesn't talk about the color of the sheathing, but it's almost identical language. But now the language that you have to copy and paste out of the regulation must show up in your report in 14 font bold.
Which is
14.
really, really big compared to the rest of the stuff in your report. Yeah,
That's Maryland.
that's Maryland.
The
So
election.
what you guys got to do is just copy. I need something to drink. What you guys got to do is just copy and paste this stuff right into your report, your contract, whatever. But it is huge compared to everything else in my report, and bold.
So we'll give Tony a chance to look for that. We'll move on. But when you raise your hand, Tony, when you find it, we'll have you read that to us also. Why don't you keep going, Jim?
Yeah. So there are times you do have to call in outside forces, like the guys who grabbed the lightning bolt. This was a POS flip in Fredericksburg. I didn't want to go to Fredericksburg. The realtor insisted I go to Fredericksburg. The realtor thought I charged too much. Well, I'm sorry, I'm going to Fredericksburg. I should really be charging more. Well, I'll have to pay you because she can't afford it. Well, if she's buying that house, she can afford it. So I'm inspecting this POS. It's built on a crawl space, 3-4 steps down to the laundry room, unfinished, utility room, boiler, furnace, stacked washer and dryer right beside the steps. So I'm walking down the steps and I walked by the washer dryer and I was like, that didn't feel right. Just a little like buzz. And then the washing machine wouldn't work. So then I'm checking outlets and they're not reading right. And I'm like, there's something going on here. So I walk out through the yard, follow the line to the pole. There's the neutral. Already been fixed once. You can see the repair. We have no neutral in the house. No return path for the current except for whatever crappy ground system there is, right? Which is not great. But then it got worse because I still have the emails. Dominion Power, or whatever the power company is down, there's nothing wrong with it. Oh, but what? You saw it with your own eyes. I have the pictures to prove it. No, there's nothing wrong with it. Who gets to drive back to Fredericksburg for free? Me. I go down there, and sure enough, one of them fixed it and didn't tell the rest of them. Anyhow, they got that taken care of finally. Then I got this one from Sean Troxel. I don't have a pointer, but I think you can see it right here. Yeah?
What point again, Jim? I got the camera.
Right there. Neutral wire hanging. Over here. This way.
There we go.
Right there. There it is. There's the neutral. 2 shots of that. Here's the other shot. That's the other. So it doesn't hurt, especially if things aren't checking out right, things aren't working in the house. It doesn't hurt to take a walk out and check the wire, the service drop. I just got this one from Scott Robertson a couple days ago. It's a flip in DC. 2 meters, house has a separate basement unit, 1 knife switch on a trough, 2 conduits out the bottom of the trough. Scott couldn't get the knife switch open, but the buyer got it open and took a really bad picture. There are only 2 fuses in the knife switch. And I'm thinking, where are these meters separated? Where's the other cable? How do they have a 150 amp in the basement and a 200 amp upstairs? Where are the cables? Don't know yet. There's only 2 fuses in the knife switch. That's only going to be 1 service. Anybody ever seen anything like this in DC?
Yep.
What'd you see?
Huh?
What'd you see?
Exactly like that. Exactly like that, yeah. And I wrote it up in the report because I couldn't figure out what's going on.
Were you able to get the switch open?
No.
I
could move the switch.
So these old boxes, you usually have to turn the switch off to open the cover.
Correct.
But I would expect to see 4 fuses.
Yep.
This box, even with the crappy picture the buyer took, was made for 3 fuses and it only had 2 in it. And I'm like, where the hell is the other service running? I can't see it. Anyhow, we'll find out more about that. This is a more modern version of that, but they're not labeled. You don't know which unit it goes to. Okay, grab a mic. Right behind you.
So Tony's going to read us the Maryland regulation on CSST.
Actually, it reads very similar. If the presence of flexible gas piping composed of any shade of yellow corrugated steel tubing, CSST, was observed during the home inspection, the disclosure in 14-point bold that states as follows. Manufacturers believe that yellow corrugated stainless steel tubing, CSST, is safer if properly bonded and grounded as required by the manufacturer's installation instructions. Proper bonding and grounding of CSST can be determined only by a licensed master electrician.
There you go.
Wrong. So they're both mentioning yellow, but what Maryland says is any color of any shade of yellow.
Any shade of yellow.
Any shade of yellow. I had that wrong. Okay.
Yeah.
That's
I
what
thought
you
that's
said.
what.
This is any shade of yellow.
Yeah. Yeah. Thank you, Tony.
I've heard there are 2 ways to bond it. One is back to the electric panel, or you can drive a ground rod at the gas meter and bond the gas meter.
That makes sense.
Yes.
Or you cannot go to the ground is not the same as bond.
So I think at one point, several years ago, or more than several, that was considered, a ground rod was considered okay. But I think that was just for a short period of time. Now it's changed. You've got to get back to a service disconnect or a panel. And if you have some CSST and some steel pipe, you can go anywhere on the steel pipe in the system. I had a new house just a couple years ago, another 2-point-something million. There's the bond over there on the gas company side of the gas meter. And they didn't have enough wire there to get over to the customer side of the gas meter. I was like, okay, have fun with that one, guys. Yeah.
So based on what you know, or maybe somebody else in this room knows, would an electrician know what to do?
Not necessarily. I mean, we see a lot of electrical screw-ups, so some electricians would know what to do. That's why when I find a good one, I always recommend him, because he knows what to do. Most of them apparently don't know what to do. Yeah, Lou.
Well, with the specific language in Virginia about 2006, what do you do with something installed after that, like even today, that isn't bonded?
You still got to say something.
Well, I understand, but it's a little ambiguous with what they're requiring when there's a bigger issue about something even more recently that isn't properly wired. It just, I just find it odd the way they've included that provision.
Oh, well, yeah, because DPOR was figuring that county inspectors would catch it, right?
Yeah, they're not.
But we know about county inspectors, and we know about electricians. So it falls to us to mention it to the buyer, who can get somebody to figure it out. Like I said, I'll give them my electrician's name and contact info and website and blah, blah, and there you go. Yeah, because, yeah, it's like the one that I saw that was bonded to the gas company side of the meter, which does nothing. I hope everybody in here knows the gas pipe in the ground is not metal, it's plastic. And the little wire coming up is a tracer wire so they can find their plastic pipe. I saw one with a wire nut on it. Somebody thought it was electricity. Usually, if something looks right, it is right. This is the meter base with the 2 meters I just showed you. Usually if something looks wrong, it is wrong, okay? And I don't think this is the one that had all 5, 1, 2, 3, 4, no, this isn't the one. I think it was 5 meters that had the seals all cut. But when you see a cut seal, you want to be very careful with what you're looking at, because usually that indicates somebody has replaced a panel without a permit. Yeah. And some of them are pretty clever about how they cut it and they try to stuff it back in there, but you can usually tell if it's a little distorted. While you're doing your walk around the outside of the house, remember the missing eyebrow? Don't forget to look at everything. Loose weatherhead. This duct seal right here is actually there to keep water out. Inside that hub is this big fat rubber washer. That seal is supposed to keep water out. But the same thing happened here apparently that happened to the space shuttle. It doesn't work. So we have to use duct seal. The duct seal that Home Depot sells is interior use only. This is electrical duct seal. Electrical ducts run in slabs, pop up different places. Their duct seal will last indefinitely inside where it's not exposed to the weather. Rector Seal makes inside and outside duct seal that you can paint. They make a better duct seal. You can't get it at Home Depot or Lowe's. You have to get it from Supply House. 10 pugs at a time.
Or thumb gum.
Who makes that?
Thumb gum? Oh, God, that's standard stuff. It's been around for a bit. As long as you
What? Who makes it? Where is it? Who sells it?
buy it on Amazon, you can buy it on,
What am I looking for?
you can buy it. Thumb gum.
Is it like duct seal?
Thumb gum, yes.
Okay.
He's saying thumb gum.
Yeah.
THUMBGUM.
BGUM. Yeah. I've always used
You can
duct.
buy a 1 count packet, you can buy an 8 count.
Well, I've always seen duct seal. Yeah. Anyhow, there's that big nut with the big fat rubber washer under it. And maybe after a few years, the rubber shrinks and you need to get a couple more cranks on that big nut. Remember I said if something looks wrong, it usually is. What's this house in Arlington? 1,500 square feet, 1,600 square feet total with a little addition. 2 HVAC systems. 2 HVAC systems. A total of 5 tons of cooling. Count the fingers. 5 tons. And I'm thinking, this is really screwed up. Okay? And the unit is up in the attic, upstairs. So we have wires going up the outside of the house. Can anybody read that? What does this say? Up there near the top, right past the words ground. Type NM, non-metallic, dry location only, not UV protected, indoor use only. So we don't know if that was the HVAC guy or the electrician. They're both about mediocre usually. This looks all kinds of sketchy with all that stuff hanging up there, but that's Dominion Power. Okay? But if you look again, the weatherhead's not secured. Yeah.
Wait a minute, Jim, can we go back? Because
How far do you want to go back?
well, just to that, your two units. Well, I realize we're talking about electrical, but what's going on with 5 tons of cooling in that little house?
So this is what's going on? Okay. So this is like a 40s or 50s house, probably mid 40s, mid to late 40s, early 50s. No central AC, system designed for heating only. We always add air conditioning. What happens to these systems? These older systems designed for heating only, smaller ductwork, slower fan speeds, right? Now we want to cool the upstairs. What do you have to do to cool the upstairs of this house? You got to get all the insulation out of the attic, air seal the attic floor, get R49 up there, hopefully cellulose, and you've got to aero seal the ductwork. Because the ductwork leaks in these houses 40, 50%. But we have ductwork that's rated for heating and that leaks. What happens when we seal it? We don't get enough air moving through it to keep the evaporator coil happy. Then they have to add supply and return in the basement just to get more air moving across the coil. At that point, the upstairs would probably cool off fine with a 3-ton unit. Or 2-ton, whichever one's which. I just remember there's 5 there. But nobody could figure any of that out. So they figured out the best thing to do was to, I think it's 3-ton for the main level, 2-ton for upstairs. So now the main level is way oversized because it's a third of the house is cut off the top of it. And we put 2 tons upstairs. But we haven't fixed the air leakage, the ductwork, or the insulation.
So we're going to have a house that's cooling without dehumidifying.
Right.
And we have indoor air quality problems.
Right. Yeah. You still got leaky ductwork, leaky house, leaky attic, not enough insulation. So it's a mess. It'll short cycle, house will get cold, and it'll be clammy.
And grow mold.
And grow mold, yeah. Yeah. You probably need about 10 dehumidifiers in that basement.
Out of curiosity, did they bifurcate the air supplies between the lower and
Did
upper
they
levels?
separate?
Or is the second level upstairs
They just added.
just added?
Just
and
added.
So it's redundant to the upstairs?
Yeah.
Yeah.
Yeah. It's a mess. 5 tons of cooling. Crazy. Okay, Dominion Power. Nice job, guys. This is down the country, the mast broke. I
I'm
had
sorry, can you go
gravel
back to that just a second? I didn't get you flipped over. There you go. Thanks.
Oh, it's a loose weatherhead. And all that tape and connector stuff is Dominion Power. Doing a nice job. I could say more about Dominion Power. This is down the country, obviously. So what happens when your mast gives out? I just grab a ladder and
So is the ladder holding the masthead or is the masthead
ladder's
holding
holding
the
the
ladder?
mast.
Okay.
The ladder's on the mast, and the mast is secured in the downspout.
Okay.
No, it's actually, I think it's next to the downspout, and there was
Oh, you reckon?
yeah.
Oh, okay.
I think the mast is wood in this case, and it just rotted where the water got through the shingles around it. The aluminum ladder is bonding the whole mess. It's also, the service cable is resting right on the metal rung of the ladder.
And I took that picture, and that cable drew right down over the yard where the child's playground was.
Oh, yeah.
How close was it? Was it,
About 6 feet.
so you could reach up and grab it?
If he was on his swing set, yeah.
Hey, guys, we need to use the microphones because it really does annoy the remote people.
And there's like 19 of them, and there's only 15 of you. You don't want to piss off the remote people, okay? This is your picture? Thank you, Mike.
Yeah.
This is a new $2-point-something million house in Arlington. We're not going to get into everything that's wrong here. We're just going to deal with the electrical part of it. These boxes are, of course, mounted behind the 2 units. Check it out. Drywall screws right through the fiber cement. check out the concentric knockout. Check out the supply wire coming into the box. Yeah, you got to know what's wrong there. There's no wire connector. The concentric is messed up. And the other stuff, I think, is pretty obvious. The drywall screws are going to rust because water's going to run behind the panel. They're going to rust and expand, and they're going to start leaking through the fiber cement. Blah, 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 blah. You know the rest of the story. We're getting closer to the
Is
other
that
problem.
that's a shard of metal right there, right?
That's,
Yeah, it's a shot, yeah.
yeah, this is the knockout right here in the middle, the round slug part. And this is the concentric that's broken. And that's when you need one of those repair lugs. But look closer. Don't forget the missing eyebrow. What else is wrong? Anybody see it? Who said neutral?
It's Nick, the neutral. He's nicking.
Yeah.
The neutral is
Yeah.
nicked.
A nick in the neutral, yep. After dragging it through that concentric, yeah, probably take your finger off. And of course, this is the box on the right, pretty much the same. No nick in the neutral, but the rest of it's all the same. What do you get for $2+ million in Arlington? They got the concentric cleaned up there, but it's all gone. It's in a hole. The connector's in a hole. Strain relief. This might be Ruben Saltzman's, I can't remember, or Mike Casey's, I forget. Fortunately, it doesn't drip right in the box. But this is one of those shaky situations where somebody's running aground to something. There's the little strap thing that's not quite a clamp with the green wire running. Yeah. What happens here on the outside? Weather-resistant receptacle in-use cover, right? The gap, that's the foam. You looking at the foam? Yeah, the foam. Weather-resistant outlet, in-use cover. Panel clearance. Anybody? Got any thoughts? I looked at that and I really felt sorry for the electrician who had to wire that box in there. This is a fourplex in DC, and they'll have one in the entry. There's usually a little closet with a gas meter, or 3 or 4, and then another little closet with electric in it. Usually the electric's on the back wall, so you can at least face it from the front. Now it's on the side wall. I can't imagine having to wire that box. This is a friend of mine in Illinois who got divorced and had to buy a house in a hurry. And he was very distressed about the house he bought in a hurry. And part of what was distressing him was because he had recently retired, and the house that he was in with his wife, they were both paying for it because they were both working. And now he has to buy his own house on a retirement income. So he knows the house has problems. It's all very distressing. I was coming back from California. I said, look, I'll stop by. We'll get you sorted. So I started with the electric panel. It doesn't look like it in the picture because the angle that I'm at, the water heater is actually partially in front of the panel. It doesn't look like it in this picture either, but it really is. I'm still over at an angle. The reason there's a circuit hanging out there, you see a breaker on top of the water heater. It was an off-brand breaker. I replaced it for him. We did not fix the low voltage in the cabinet, in the line bolt cabinet. That transformer is still there. And the gray cap in the bottom, you can see that the panel was actually altered for some reason. it's cut away right in front of that bottom knockout, and the bottom concentrics are all messed up. That still needs to be fixed. This got final approval. I'm here to tell you, when that electrical stuff was put in that house, they did not have those green stickers. So I don't know what got approved. Did they approve meters? I don't think so. Maybe. It's DC. Who knows? It's the Wild West over there. But there you are. I wouldn't approve any of that. Blue fuses are 15 amp. Green fuses are 20 amp. Orange fuses are 30 amp. When you think about stuff that's in a house, what's 30 amp, 120 volt? Nothing. Absolutely nothing. Everything 30 amp is 240 volt. There's an orange fuse, 2 green fuses, 1 blue. You go to the bottom, all green except for 1 blue. Do we really think this old building in DC has a bunch of 20 amp circuits? Hell no. Look closely at the panel labels. They tell you about the panel. I've read lots of panel labels. Sorry, I don't have better pictures. I actually went to Home Depot to get a bunch of panel label pictures, and some jerk at Home Depot had gotten the tape out and taped all the boxes up. I mean, they were all open at one time, and you could just pull them out and get pictures, right, and look at them. No, they're all taped up now. Anyhow, Square D, Home Line, Schneider Electric, HOM 3060, 200 amp. 3060 tells you how many circuits can go in there. You can go up to 60. Then if you look below that, right down where the ground wire is, use only Square D accessories and breaker types. And they do let you use a QO breaker in the Home Line panel, same company. This is Lou's job out in Aldi. I don't have the outside picture. The outside picture has a CL320. It was a CL320 meter, right? It was right meter?
No,
It was a 200 meter
yeah,
from the old house?
no. That was a new service on that.
Okay, so it was a CL200 meter, which is 200 amp. And it had 2 service cables coming out the bottom of the meter base, which tells you what? 2 panels inside, right? Usually your disconnect is on the outside. But I guess they figured the fireman would know to look inside where the meter base is and see the disconnect for the other panel that is way the hell and gone, way over there on the other side of this 8,000 square foot addition in the old house. Then you get over there to the other panel, it's in the water treatment pump room thing with the chemicals and the humidity and moisture, condensation. Those things condense all summer, right? This panel, old. I suspect it's way over on Boxville. I counted the breakers. It's overloaded. It's got 2 tandems in it. I think you can see them. Can you see them? Tandem here and tandem up here somewhere. Anyhow, it's overloaded.
I think we counted 44 in that.
Yeah, because there's 2 tandems. Yeah. And we couldn't see the label. The label's in the side of the panel. Look at all the wires in there. You don't have a hope in hell of seeing a label. And it's recessed too far, and the gap at the side is more than 1/8 of an inch. And there's one set of tandems right above the 240s, and there's another set of tandems further up. But again, you're looking for the missing eyebrow. Here it is. Oxidation. Oxidation all the way up the ground neutral bus. What does oxidation do to electricity? Oxidation is an insulator, right? Current does not like to flow through it. It's time to change that panel anyway. They probably need a 4080. And the new panels are up to 84. And Scott was saying, even newer panels, 400 amp.
Single panel, 400.
400 amp, how many breakers? Like 120?
42.
Huh?
42.
That's crazy.
44. I've seen 60.
Oh no, we have panels now that are up to 84. Yeah. For a regular 200 amp panel, you can have 84 circuits. I would think a 400 amp panel would be 160. Anyhow, I know that we can go up to 84. That's a fact. I did see that at Home Depot. Oh, and this cable for this, going to this old panel, this basement is huge. Do you think that basement was 4,000 square feet? It's at least 3, wasn't it? It's way,
At least 3.
it's way across the house. I mean, guys, they had one HVAC system in there that was 70 feet of duct, one direction, with 14 elbows. And this room that had a bunch of glass that wouldn't cool. I'm like, dude, you look at the ductwork, 70 feet of supply, 70 feet of return, 30 elbows, whatever. It's not going to work. And that system wasn't just serving that, it was going to other places. The cable, the service cable for that old panel was sort of hanging up on top of the ductwork against the straps that hold the ductwork. And this is probably a different house, but what's wrong here? Anybody see it? Yeah. Yeah.
Metal twist tie.
With a little twist tie. The insulation's screwed up too, by the way. It's fiberglass, number 1. And it's missing right there, number 2. And where it is installed, it's not installed right.
That twist tie.
Make the green light go on.
Make the green light go on.
Yeah, there you go.
That twist tie is a metal twist tie that cut into that wire also, wouldn't it?
Probably not.
No?
It's got plastic around it.
Okay.
It's probably not vibrating that much right there.
Yeah, I'll go for us. I mean, I've got one of those.
TMI, Tony. I should dig up the old PowerPoint that has the one that says penis head on it.
That's a good one.
And what was the other one? It's labeled something like right here. And when you flipped it off, the light right there went off.
I had one yesterday labeled fart fan.
You never know. This one is actually up there at the top. It's for Nance B. Look at this panel. Doesn't that look nice? Didn't somebody do a neat job there? Looks great, doesn't it? Except the box isn't bonded. Yeah. Other than that, it's pretty tidy. Why does the box need to be bonded? Anybody know? Anybody know? Why we bond the box? Okay, I'll tell you. There's all this electricity in here. If it gets on the box and you touch the box and you're standing in water, you're dead. You will die, yes. That's why the box gets bonded. None of these breakers are in use. That's a good thing because the ground and the neutral are together. So what does that do? That causes objectionable current. So electricity is a difficult concept to grasp. Anybody that says, what do they call it, the neutrons? Electrons. Anybody says the electrons are flowing? They're not flowing. They're sitting in the wire. Yeah. So what happens with electricity, guys, just to make it simple? What happens, you have one light here, you flip a switch, and that circuit is going, that's one circuit, that's all that's on that. What happens here? When you flip the switch, the light uses the voltage. There's still current there. The current is returning on the neutral. It wants to go home. It wants to go back to the transformer. So there's always current there. There's enough current there to kill you. Okay? The light used the voltage. The voltage is gone. Once you get past the light, the fan, the whatever the hell it is you're running, there is no voltage because that thing that you turned on used it. The current is still there. So when you get into this, and you have ground and neutral together, whatever's on the ground side can get voltage, current on it. Not voltage, but current.
I learned this lesson the hard way. Very difficult house. The problem was, through the whole inspection, the lights would just flash in the house.
Yeah.
All over the house.
Yeah.
For no apparent reason.
Yeah.
They would just flash.
Yeah.
Couldn't figure out why it was going on. Finally traced it back in the garage. There was a ground rod. And the ground rod was arcing.
Was what?
Because the power company neutral had disconnected. So now all of that return current you're talking about was going to ground through this ground rod, and not very well.
Right.
It was like a lightning show down there.
Yeah.
Really dangerous.
Yeah. Yeah. We're gonna get to that.
So, go ahead. I want to go back to the previous one, but finish this one first.
Well, that's it for this one. We've got ground neutral together. You can get current. Current does not take the path of least resistance. It takes all available paths depending on impedance.
Go back to the two. Go back to. Oh, that's it. That's it right there. No, that was the one. That was the one. So I'm looking. You saying that the problem here is that the panel is not bonded. Yeah.
I have this picture in iPhoto and I zoomed in on it. I
Okay.
can't find a bond there.
Okay.
There's
You're right.
no bond strap. There's no bond. Neutral's over on one side. Neutral's over on the left side. Ground is on the right side. They have the ground coming in. That's the green wires. Yeah,
So there should be a bond strap on the
there should be a bond strap on the ground side,
but not the neutral.
because it's mounted up off the cabinet. It's not right directly on the cabinet, right?
Well, because it's a sub panel.
Well, it doesn't matter. The ground bus can be right on the panel. It doesn't have to be isolated from the panel. If you isolate from the panel, then you got to put a ground strap on it. Are we good?
The neutrals and the grounds are isolated because it's a sub panel, right? The
The neutral and grounds are separated.
because it's on a sub panel, because it's a sub
Separated,
panel,
right.
Because it's a sub panel.
Neutral's isolated from the grounds and isolated from the box, but the ground has to
ground
be
should be
bonded
bonded
to the box.
Correct. Okay.
Right.
The ground has to be, yeah, the ground should be bonded in a sub-panel.
Oh, yeah. That has
The ground side has to be bonded to the box. The box always needs to be bonded. Because if anything got loose in here, like somebody left a wire loose and it ended up touching the box, you got to have current everywhere.
Well, the other issue is that if you've got a ground fault to the box, the breaker won't trip unless you have a return path. You need a return path to cause the breaker to trip.
There used to be something, maybe a purple label for that required anti-oxidation paste, but I don't feel like I'm seeing that anymore.
for aluminum one.
It's for aluminum,
It will for your service.
antioxidant.
Right.
Yeah.
But I'm not seeing the purple sticker anymore.
Bean counters, it saves money. But yeah, we should use antioxidant.
The reason I bring that up is the way I was taught is, you call it out as an infraction if the label's there, but the antioxidation.
I think
paste isn't.
technically, if the device is labeled for aluminum wire and you put aluminum wire in it, you don't have to put antioxidant there. It's one of those things. Is it better to put antioxidant there? In the case of the panel that's in the damp area, yeah, you'd want antioxidant everywhere, obviously, or big dehumidifiers, right? Objectionable current. This one, next one's a head scratcher. Still trying to figure this one out. This is a 240 only panel. Nothing there needs a neutral, but they brought the neutral over. And they have a ground over on the other side. Both these buses are ground. They're both directly connected to the panel. They probably did not scrape the paint off, but there's your bond screw and the neutral and the bond screw, which means that now the whole panel and the ground system are all connected to the neutral. Right.
So what's wrong in that panel picture is the green screw.
The green screw and the neutral being connected to anything.
Neutral shouldn't be there.
The neutral shouldn't be there. You don't have anything in the panel that requires a neutral.
It's not hurting anything there until you
It's
put the
not
green
hurting
screw-
anything
until you
as-
put the green screw in.
Or until you connect the neutral wire. You disconnect the neutral wire, you're okay, right? Or take the screw out. Yeah, take the screw out. Those two buses are tied together at the top, right above the breakers.
Yeah, there should be.
They're both neutral. The ground buses are on the box, but the paint's not scraped off. What did I say about electricians? Oh, Jim, that wasn't very nice. Scott Del Monte sent me this. Are those neutral wires? They're not white. And they did use some funky colors of brown hot wires at different times, like in the 70s and 80s, but I thought it was a darker brown than this, but these aren't really white like a label.
But they're not neutral, why are they going to be reversed?
They're going to breakers, so they would be hot even if they were white. They wouldn't be neutral, they would be hot. So what happens when you have your black wire and your white wire both hooked to breakers? Then your ground is acting as a return path for the current. And we know the ground is only there to clear a fault. It's not a return path for current. So, another screw up, right? This is from Ben Moorhead. To me, that looks like a heat signature. I could be wrong, but it looks like heat to me. The strap at the back there that's riveted in is discolored. The screw in the lug is discolored. The Allen head screw, hex head screw. The other side looks like heat signature to me. This is from Ruben Saltzman. This is when your garage door opener cord is just a little too short. But 3 of those 2-prong adapters will get you there. But now you're not grounded anymore, because you would have to plug it into the other hole and put the plate screw through the tab. This next one, I think Alex Adderton sent me this one. This is how you get free electricity.
Oh, I get it.
Lamp cords, never concealed, never. This is from Ruben. Clearly there's a shelf above that people keep detergent on. The detergent leaked on the box extender. What do you say when you see box extenders, power strips, blah, blah, those things? Add outlets, add more receptacles, get rid of that thing that probably only plugs into one side of the outlet. It's all loose anyway. This one's full of detergent. Here's your very common error, disposal and dishwasher. How convenient is that? We can use one wire for both of them. What's the problem? The problem is we have a shared neutral. What's the problem? The problem is the shared neutral is on one phase because it's a tandem breaker. So it's only stuck onto one stab. What happens when shared neutral is on one phase? You double the load on the neutral. When you split it and you have the red on one phase and the black on the other phase, you cancel the load on the neutral. And, you know, some panels have so many multi-wire, these are multi-wire circuits in them. You know, they get 4, 5, 6, 7 multi-wire circuits. Who the hell is going to stand there in all that jumble of wires and try to figure out which 2 wires of that circuit are going to which breaker? You know, if you just have 1 or 2 multi-wire circuits, it's easy enough, and they're all single pole breakers. You just count them. If the red's on an odd and the black's on an even, that's opposite phases. If you go 1, 2, 3, the red's on 1, the black's on 3, they're on the same phase. Easy. Everybody good with that? Anybody got a problem with it? If you do, let me know. What's wrong here? Yes and yes. You both got it. Yeah, when you see corrosion in a panel, it's probably time to change it. When you see different wire sizes, most manufacturers say 2 grounds, 1 screw. Cutler hammer or Square D says 3 grounds per screw. Same wire size though. Always the same wire size. And why is that? Yeah, because so when I show people this, I show them like this. I say because you have a little wire and a big wire, and the screw tightens on the big wire and leaves the little wire loose. They get it.
Okay, Jim, apparently we didn't get a good enough explanation about multi-wire circuits because we got a question here. I think that you assumed people understand what a multi-wire circuit is, and then you described what was wrong in that picture, but there are people who didn't understand
What a multi-wire circuit
what's
is.
right, what would be the right thing.
So a multi-wire circuit is where you've got, instead of your standard 2-wire with ground in one jacket, you have 3-wire. Wait a minute, let me get this right. 3-wire with ground.
Right.
So this circuit that's labeled disposal and dishwasher, by the way, you have 2 hots, a black, a red. You have a white wire that we don't see, and you have a ground wire. So it's 3-wire with ground. So instead of running a circuit for the disposer and a separate circuit for the dishwasher, we run a multi-wire circuit up there. The disposer gets the red, the dishwasher gets the black, the neutral, they share the neutral.
So the reason for this is just to save a piece of wire.
Save wire and save time.
So we're running one wire
One
to
cable.
underneath the sink.
One cable with more wires to 2 devices.
Right,
Right, 2 appliances.
right.
So did that clear it up?
I don't see another question coming up, but you shouldn't
Okay.
be looking at me. Look at the camera.
Microphone, please. Turn it green. You have to push
Is
the
it green
button.
now?
Yes.
The neutral, which you can't see in that picture, I'm gonna guess is pretty bent in order to get into that bar. Are they plugging the neutral into the grounding bar there? The ground bar?
So we don't see, there is a neutral. There's a neutral up there, but we don't know if that's the neutral for this circuit. There's a neutral somewhere for this circuit.
So I think
Because you always have some standard non-metallic NM cable. You have 2 wire with ground. So you have black, white, ground, black, white, bare, black, white, copper. Multi-wire circuit is pretty much always going to be red, black, white, neutral, bare, ground. So it's going to be 3 wires with a ground.
So I think the question here is, the confusion here is that we don't run the outer sheathing inside the panel. You see 3 pieces of outer sheathing in there because the electrician took some scraps of the outer sheathing and put them on there to identify those. Right, and the reason that one is so long is because it says disposal and dishwasher.
I got you.
Right. So I could go back a few pictures, but I'm going to go forward instead and show you because it's going to come up again. It's going to come up again about sheathing in a panel. Anyhow, we're going here. Now we're going here. I like this picture because it shows you the bottom 3 breakers, the wire goes into a hole. When you have a wire going into a hole, only 1 wire goes in the hole, never 2 wires. But if you go to the 3 breakers right above, those breakers are made for 2 wires. You can put a wire at the bottom of the screw and another one at the top of the screw. The fix for this one would be to get the other style breaker or simply use a pigtail, which would be like a 6-inch piece of wire that goes into the hole and gets secured by the screw. And then those 2 red wires are connected with a Wago or a wire nut. That's the fix for, but under the screw, into a hole, 1 wire, under the screw, 2 wires. Only 2 manufacturers do that. And I don't know if they still do it. It was Cutler Hammer, and I think someone else.
Siemens.
Square D. Square D.
Square D. Oh, they do that.
Siemens bought Square D.
I have another question.
Sure.
Is that painted on installation? That red?
No, that's red wire. You're talking about the 2 red wires?
Yeah.
Yeah, they're just red wires. You can use red for hot.
It just looks kind of blotted out there.
It's red plastic. Red insulation.
Right where it gets to the,
Oh, on the breaker itself?
on the breaker itself.
Oh, yeah.
It looks like
That's what
painted on
breakers-
installation there.
Yeah.
Yeah, they're just jammed in there real nice.
Okay.
Yeah, what you shouldn't see probably is a bunch of wire up here. You don't want a bunch of wire exposed. Shiner. Yeah. I think this is what happened to the electrician.
It's the break room.
Yeah, it's the breaker.
Hey, Jim, quick question.
Hey, got a mic?
Yeah, can you hear me now?
Yeah.
Back to the dishwasher disposer, because I'm always thinking, I always want to know what the answer is. I thought, so for possible fixes,
You're going to get feedback if you bring the mic over here. So he's going back to that same picture of the multi-wire circuit again.
I'm just asking about the dishwasher disposer. I thought I'm just thinking about possible fixes. Can those 2 appliances still be on the same circuit?
They're not on the same circuit.
But
They
could
can't be on the same phase.
Right, but
Oh
could
yeah,
they?
it's an easy fix. All we have to do is add another breaker and move one of those wires to another breaker.
Yeah,
But the breaker would have to be adjacent to the existing breaker to be on the other phase.
right. But also can't the disposer and dishwasher be on the same circuit if you wanted to, if that was another easier fix?
That's manufacturing. I think the dishwasher manufacturer says dedicated circuit. Disposer doesn't draw that many amps, doesn't run that much. Dishwasher doesn't care, but this dishwasher, I think, has to be dedicated.
Thank you.
You're welcome. Why is that humming when I change pictures? You got something messed up over here. You got bad ground or something, Hollis. Listen to it. Listen to it hums. Listen, watch. I'm going to change pictures. Listen.
Yep. It's the carousel. Yeah.
Okay.
You know how to hit a guy when he's down, huh?
Okay. See this? Sometimes, guys, you just got to go for it. Grab the electricity. Okay, look at this picture. Under a sink in an old house. You can tell it's an old house because that crap board in the back of the cabinet, right? 50s, looks like 50s. Okay, so we know we have a leak at the supply cutoff for the sink faucet, right? And we know that the drain used to leak because we see watermarks on the face of the receptacle. You got a bad ground there, Hollis. Something's loose. The water pipe that's above is against the metal box there behind the cover, because we see green on the corner of the box, and that's the green coming down with the water, the copper oxide. And we know there was water getting in the outlet. We also see a black wire coming out below the box, and one would guess that that is a ground wire going somewhere. Look closely to the other side of the box. We see the copper wire coming out, going up to the water pipe with a sketchy little clamp, and then that wire keeps going somewhere else to ground something else. Then keep looking at the picture. What else do you see? We see an appliance extension cord plugged in. That's the gray one with the warning tag still zip tied to it, right? Where does it go? Bzz, to you. It goes to the dishwasher, right? Yeah. So we see all this sketchy stuff under the sink, evidence of leakage, water supply leakage, water pipe touching the outlet, drain pipe leaking on the outlet, sketchy grounds. So what happens next? Well, if you're Jim, you grab your trusty 35-year-old volt tick. Wait a minute. Will this play, Hollis? It won't play?
It was playing. It was playing. There it is.
Yeah. Yeah. Then you grab your meter. 120 volts on the dishwasher. Sink's right here. Dishwasher's right here. Don't be holding this when you touch this. Why do I have a blank slide? That's not right. This, what's wrong with this panel? Anybody? It's old. Split bus. Split bus. Get rid of it. It's old. Oh, yeah. As a matter of fact, look closely. It's a triple split.
Yeah. It's a triple split. Yeah, no,
The top is directly to the service bus. Then it splits, goes to the middle one. And you can see the split here and here. Get rid of it, replace it. Because if you're going to keep something like this in your, if you're going to keep something like this in your house, you might as well use these. The audio-visual one is my favorite, I think. That and the slow blow.
What's this logo?
The wrench, the 2000 amp one. This would be down south, probably in a warmer climate, because at the top you would have a meter, and below the meter you would have your breakers. And I can just hear Bob saying to Martha, Martha, it's a good thing we got that asbestos siding on the house. The place could have burned. Yeah. Now, we're talking about neutrals. Oh, you can't hear it. Can I have to unhook it? Where's my speaker? Let me see if I can do this. So I was turning on the disposer, okay? That was just a disposer. I think this is Tim Zenobia's house. And I said, is this still working? Yeah. I said, Tim, so this happened, but in the meantime, the lights in the hall were just doing little disco flash all by themselves. You didn't have to flip the disposer on for that. That's a neutral fault causing that. You see lights flicker, start looking for a neutral fault. Well, Tim needed a new panel. Unfortunately, at that time, I was referring Mason North, who now lives in Richmond, and Mason installed Tim's panel, and Mason would not listen to what I told him. I said, when you're working for one of my clients, you offer them a squared EQO panel, 40 breaker. He put in a home line 30 breaker, 200 amp 30 breaker. I'm like, Mason, that's just stupid. Not a good thing to do. Move to Richmond. I'm done with you. So I told Tim, I said, the neutral fault can be anywhere in the house or anywhere between the house and the transformer. So after the new panel, the flicker's still there. Tim calls Dominion Power. The fault, Dominion Power apparently has tools that we don't have because they can find a neutral fault 3 feet in the ground. And it's where the neutral crossed the polyethylene water service, right there. And I think I would have had that poly fixed while the hole was open because it's rubbed away some of the poly. But it rubbed through, there's enough expansion and contraction there, I guess with changes in temperature, that it's actually rubbing. It rubbed through the wire jacket on the neutral. And
That's not a rub.
why do I have? There we go.
That's not a cup. That's not a rub, that's a cup.
No, it was rubbing here. This is the part that was rubbing. You can see how thin this jacket is compared to this jacket. This is the bad part that they cut out. So it rubbed through the jacket. Water got in. That's how much oxidation is in this neutral cable right here. It was this size. This is the good part. This is what happened to it. And the guy from Dominion said, worst neutral fault he'd ever seen. And if it was in the house, it probably would have burned the house down. Funny thing is, two of Tim's neighbors are on the same transformer. They also had flickering lights forever, and they just sort of thought it was okay. This is a flip. Oh, you have a question? Get a mic, turn it green, please.
So with neutral fault, are we seeing the flickering lights throughout the entirety of the house as a symptom, or is it on a single circuit? What are we looking for?
I can tell you my house has a neutral fault, not as bad as Tim's. Every time the dryer starts, the lights anywhere in the house will flicker. So it's probably lights just like at Tim's, and it may have been the kind of bulbs they're using. LEDs act differently in different situations. They may have had LEDs in the hallway. They were just sort of doing a little constant flicker, right?
Right.
But these lights, when I flipped the disposer, I could see the lights in the dining room and the overhead lights in the kitchen. They were all blinking.
But a constant flicker is also a
It
sign
could
of
be a neutral fault, or it could just be the wrong kind of switch for the light fixture.
or a bad contact in a particular
Could be a
fixture if
bad
it's isolated.
contact. But if you flip something on that draws power and you get a flicker, neutral fault.
Okay.
Mike?
Anything with the panels over there, or are you gonna skip that?
Am I out of time?
I think we got it started.
Oh, crap. Well, here, we'll get a few more here. Yeah, the panels are fun, but we'll keep going here. This all looks nice. This is a flip. It's all new work, right? Look at it. Look at it. You see it? Do you see it? Do you see it? Are they saving electricity or what? This is a brand new flip. I have no idea what they were doing. They're running the whole house on one leg, one phase, one leg, one phase. I can tell you what happens to houses on one phase, because when I ran a screw into a service cable, putting the cover back on, that much of that 4-aught cable disappeared, vaporized, and everything in the house was half bright. Nothing 240 would work. Kind of creepy. Okay. Trip, trip. Oh, look, here comes the smoke. I let the smoke out. You have to get a new GFI. So I'm like, trip, damn it. I'm just gonna keep my finger on it till it trips, or until the smoke comes out. There we go. We gotta get this one in. See anything here? Look closely. The first thing I saw when I opened the panel, long before I put my sticker in it, discoloration. These guys are discolored, especially this one. Then the second thing, you're looking up here anyway, then you see broken stuff up here. It's all broken up there, right? So, yeah. So anytime you see discolored stuff in a panel, that's a heat signature. That should tell you something right away. The electricity is having a problem there. It's not making it through that connection easily. Something is slowing it down, holding it up, and it's generating heat. This panel is trash. It's done. Nobody's going to take it apart, try to get the parts, put it back together. They're going to replace it. That was just last year, by the way, 22. So then you get your fancy infrared camera out and look, what do you got? One of the lugs is hotter than the other one. Yeah, well. Integrity of electrical equipment. Did we have this one already? Internal parts of electrical equipment, including bus bars, wiring terminals, insulators, and other surfaces shall not be damaged or contaminated by foreign materials such as paint, plaster, cleaners, or abrasive and corrosive residues. There shall not be any damaged parts that might adversely affect safe operation or mechanical strength of the equipment, such as parts that are broken, bent, cut, deteriorated by corrosion, chemical action, or overheating. Foreign debris shall be removed from the equipment. How many times are you in a new house and there's all kinds of sawdust and wood shavings and drywall dust and whatever else the electrician throws in there? Decades ago, the electricians always left their cigarette butts in there. You might still find them in an older house. Foreign debris shall be removed. The house cleaners don't go in there, guys, I guarantee it. What do labels tell you? Labels give you a lot of information. This is an older panel, but it still tells you where you can put your tandem breakers. These are the tandem breakers you hardly ever see anymore. They were wide, they weren't skinny, top to bottom. They were wide side to side. 2 breaker handles, 2 breaker handles. This one's even older. And again, they tell you where you can put your tandems throughout the panel. And up top, they even tell you where to put your neutrals. They're numbered too. That's your old Pushmatic. What's wrong here? Supposedly, if you have an equal number of wires under each screw, supposedly it's okay. It's not best practice. Same thing here. Is there a solution? There's an easy solution. The Bud Light drinking electrician just needs to, wait a minute. Look at all the wire jacking in there. The Bud Light drinking electrician just needs to have a box of 500 of these in his truck. He'll never have that problem again, won't have to split the wires. No paint scraped off drywall screw. No paint scraped off drywall screw. No paint scraped off on the label drywall screw. What's in the closet? Federal Pacific stab lock. You can tell by looking at it. It's Federal Pacific. That's what you want in your closet if you want to die young. Well, fortunately, they missed the service entrance cable, or the screws weren't long enough for the close rod. Otherwise, yeah. And I can tell you what happens when you hit a service entrance cable. So yeah, this is going to cause some of your heads to blow up, but that's okay. This is a Federal Pacific stab lock panel. Do I open these? Yes, I do open them. Okay? The breakers will fall out, or they won't. If they fall out, I stick them back in and put the cover back on. But I want to see what's inside. What's inside? It's all rusty, it's all crusty. You can kind of tell that from the outside, but it's even worse when you open it up and look in it. It's wet location. This thing is condemned for multiple reasons. The first one being stab lock, right? Although some people don't have a problem with stab lock, I do. And it's old. This one, guys, okay, wait a minute, don't leave yet. This is a Bryant Westinghouse, okay? So this friend of mine calls me and says, hey, Jim, my panel's buzzing. Can you come over and look at it? He lives in a condo. It's summertime, it's August, it's hot. Take a look and pass it on. Bryant Westinghouse panel, right on Route 7 in Falls Church. I go over there, sure enough, it's buzzing. This is what Bryant breakers do. Look where it was, look at it. It just got burned away. The bus was burned up too, but it was still running the heat pump somehow. This is a Bryant Westinghouse panel. Somebody else took this picture. It might have been Sean Troxel. It's got a date code on it.
Look at the amount of branch, look at that thing, that's just.
Yeah, look at it. And it's got it wrong. It's got an off-brand breaker in it. Yeah. I'm almost done. 12-2 AL. But what does it say after AL? It says CU clad. This is copper clad aluminum. You treat this the same as copper wire. This is a $2 million plus custom built home in Arlington. The genius electrician modified the panels. The panels are both damaged. They're both bent at the bottom. But he drilled 2 big holes in the top, and he bundled all of the branch circuits together and ran them up and up and up, bundled, and over and over and over bundled. I'm like, okay. He screwed up both panels, then he bundled all the wires. They're not derated. It's a mess. In a $2+ million custom built for the owner of the company.
That'll do it.
That'll do it. You'll find them every time. And that right there, electric art.